Imagine you're sending 10,000 from your bank account to your friend's bank account. The database is supposed to do two things here. Deduct 10k from your account and increase 10k in your friend's account. But imagine the server crashes in the middle of this process, deducting amount from your account, but never crediting the same amount to your friend's account. That'll be a disaster, huh? Yeah, how does databases prevent situations like this? This is the exact concept of transactions to avoid this kind of situations. And because my lack of animation skills, it was pretty clear what transactions have to do. Now let's go on and perform transaction stuff on our databases. Let's start this video by setting up the database real quick. I've already written my stuff in a notepad. I'll just copy paste it so that it's easier on me and it's time saving for you as well. So I've set up a bank DB database. I'll create a table inside it. Let's call it accounts. Account ID is the primary key. Holder name is varchar of 50, and balance is a decimal of maximum 10 with a decimal space of 2. Let's go. Now let's insert some values into this. Yeah, let's put my name and a random name. Let's call him Aryan or something. That would be fine. Here we go, and good to go. Now let's check what data we have so far. We are having account ID as 101102, me Aryan, 50k, 30k. Aryan is not broke this time, as you saw in the animation. So proud of it. So yeah, what problems do we face without having transactions? Let's try the exact process which we discussed in that animation which I made. So the first thing which we'll be doing is deducting the amount from my account. I'm setting the balance as balance minus 10,000 because I'm sending 10,000 to my friend. I press enter. Here we go. 10k has been deducted here. And now what we do, we add 10k to Aryan's account. Here we go. Both the changes have been made. And both have 40,000 each. But imagine after this process, if the server crashed or there's a power outage, any other issue that's possible, then money got deducted from my account, but there is no amount credited to Aryan's account, which means that I've lost my money. Money disappeared into nothing. So how do we basically use transactions, right? Because that's how we avoid this disasters from happening. So we basically just have to write start transaction. Done. We can also write begin instead of that. Now let's see how we actually use it. This was just the syntax for that. How we actually use it: use start transaction, then we put the update code for the first thing, deducting the 10,000 to go, and next thing, which is adding the exact same amount to Aryan's account, and done. Now what do? Basically commit our changes, whatever we have made, and commit. Now if we check, where is it? And now I have 30,000 and Aryan has 50k. Fair enough. So commit basically permanently writes all the changes to the database. We have verified the information. Well, now what do I do if I want to roll back? Let's first set everything to as it was. Yeah. Now let's start a transaction. We started the transaction. We deduct our amount. Good. Now let's take a scenario where the server has crashed right now. If the server has crashed, then I do not have to lose my money here, right? I don't want my money to disappear like that. So what I'll do, I'll simply use the rollback, and 0 was affected. But let's check the thing. As you can see, no money has been deducted so far. It got deducted, but it got rolled back. So I have not lost my money here. Yeah, I hope that's clear. Let's move on to the next thing, which is the save point. Save points, basically, if you have played GTA, in Vice City and San Andreas, I think, from what I've played, they used to have these specific checkpoints with, if you go there, you can save your game, whatever is going on, whatever progress you have so far. So save point is exactly the same thing. We can save our thing as we want it to. Let's start a transaction. Let's deduct money from my account. Not up. And I've deducted some amount from my account. Now let's put a save point here. Save point, it's called transfer 1. And let's do the second transfer now. Second transfer is done. Now let's roll back to the save point, because let's assume that, let's not assume, let's look at it. We have deducted 5,000 from my account, but I have deducted another 10,000 for some reason. So that second one is incorrect. So we'll have to roll back to our save point. This is the save point. So this change would be neglected. It would be not applicable anymore. Good to go. Now let's commit our changes. Commit done. Now let's check our data. Have I lost any money? That should be 5,000 deducted from my account. Accounts, and let me go. Yeah, I had 50k, I have 45k, which means 5,000 has been deducted, which is fair enough, because let's say I made some payment somewhere. Yeah, and there's one more thing which we need to consider is, why do updates usually save automatically? Because AUTOCOMMIT exists. AUTOCOMMIT means that everything we do is committed by itself. We don't need to manually commit it like we did here. So we need to consider this as well, that AUTOCOMMIT exists, and we should make sure that it's enabled where it needs to be. It's not enabled where it's not needed. Right now it's not enabled. 1 means false, 0 means true. So AUTOCOMMIT is false, which means it's not on right now. Let's change this to 0. Set now, then its value is 0, which means that whatever I do would automatically be committed. As a statement is now its own transaction. There is no going back from now. But to be on a safer side, I'll simply change this to 1. Back. Good to go. Yeah, I hope that's clear, because the next topic which I'll be covering is pretty important as well. It is called the asset properties. You may wonder what does asset have to do with SQL. Asset is not the asset which we see in chemistry labs. Asset is atomicity, consistency, isolation, and durability. Let's understand them on the whiteboard. I'll simply just right here. Yeah, so the first thing of asset properties is A is for atomicity, C is for consistency, I is for isolation, D is for durability. Okay, now let's discuss each one of them separately. Atomicity means that all operations happen or none of them happen. So either the transaction gets completed on both ends, the sender and the receiver, or it does not happen at all. Example are booking a reservation ticket for a train ride, or maybe booking a ticket for a movie. These are the examples of atomicity. Consistency means the database should remain valid. Let's take an example. I had 50,000, Aryan had 30,000. Write it out. Me, friend, I had 50k, he had 30k, but after transfer we had 40k and 40k each. So the total of this transaction and the total of this transaction should be equal, right? Because there is no money leakage or no money sidelining in this. This would be 80k, this would be 80k as well. Why? Data remains consistent. That's it. Isolation, which means user A transferring money, B checking the balance. Database prevents both transactions from interfering improperly, which means that each transaction behaves independently. They are not dependent on each other or anything else. Yeah. Durability here means that when we commit the changes, whatever changes we have made, when we commit them, then anything that happens should not be changing the values unless I choose to do so. Like after commit, if power cuts off, the server starts to restart or something, or whatever else that's possible, it won't make any changes in my data unless and until I allow it to happen. That's what commit is supposed to do, right? I should not basically lose the committed data. That's the point here. Now let's take a look. Let's perform the entire banking transaction. Single transaction. This here. Explain everything, don't worry. Starting the transaction, updating the account balance as minus, so deducting 10,000, where account ID is 101, which is mine. Then I'm updating the account of Aryan. I'm adding 10,000 to it, and I'm making my commit. If I press enter, the changes are saved. If I do rollback, then both these changes would be ignored. They won't be made from start transaction onwards. Whatever changes I have made would be reverted back to their original form. But after I press commit, there is no going back. Let's press enter and happen. Good to go. Yeah, next thing which we need to discuss is some real life applications of transactions. A good example of it is money transfer, as we saw. UPI payments. If you are in India, you know what UPI payments are. E-commerce, creating an order, reducing stock, generating an invoice, creating payment entry, all inside a single transaction. Ticket booking, as I discussed before. Ticket booking, reserve seat, process the payment, generate the ticket, all inside a single transaction. Yeah, I hope that's clear. I hope it's worth watching. I'll just promote my channel a little bit. You can skip like 15 seconds or something to end the video. So this is our channel, Decoded. We have 48 subscribers and 35 videos. We have 2 courses out already, which is Python for Absolute Beginners and Oops in Python. Video you're watching right now is the part of this 3rd course, I would say. That's SQL Roadmap series, and it has how many videos? 11, and counting this one at 12 videos so far. Yeah, if you like this video, please do check out the rest of it as well. Sure, it's worth it. Yeah, let's end the video with a single line. The database can recover from bugs, crashes and failures, but only because transactions guarantee that partial work never becomes permanent. Yeah, that's the end of this video. I hope to see you in the next one. Till then, keep learning and have fun.